projects utilizing various aspects of the blockchain technology have garnered sizable investment and support, attracting the attention of the financial community and regulators. But where does the true potential of blockchain lie? And how can we distinguish this groundbreaking innovation in this space and navigate the complexity of regulation? So these are some of the key questions that we're going to be attempting to answer tonight with our distinguished industry leaders. And to set things off in that direction, I'm going to invite you now to join me in welcoming to the stage Dominic Williams, President and Chief Scientist of DFINITY, to give a brief introduction of DFINITY and their creation of the decentralized Internet computer. Dominic.
So, first of all, thank you everyone for coming. Thank you, NASDAQ and Bruce, for hosting us. We're so happy to be here. It's a sort of amazing opportunity. So I'm going to introduce DFINITY very quickly and then talk a little bit about the different kinds of tokens that are out there in the wild. DFINITY is a blockchain supercomputer that's designed to host the world's software and data. It's a kind of open public cloud 3.0. So apologize to DFINITY fans who've already heard all this before. So, mid-20th century, computers had already been described mathematically. And it wasn't long before people started making computers, physical computers. An early example would be the machine at Bletchley Park in the UK that decrypted German communications during the Second World War. In current times, of course, when we imagine a computer, we think of a physical computer like a kind of rack server like this, or a laptop, or a smartphone, something like that. What's important and interesting is you can also create a computer from a network of computers. And that's what the Internet computer is. A number of different computers, potentially tens of millions of them, or even hundreds of millions, distributed around the Internet, connect together to create a single shared computer that is a public utility that we want people to host software and data on. And of course, the power of this idea includes new computers connecting to grow the capacity of this public utility. So you can install more software, run more computations, and store more data. So you might ask, what runs on this Internet computer? It's actually something called WebAssembly. So WebAssembly is going to be enormously important and in tech in the next few years. And it's the world's first open standard for universal software that runs anywhere. And currently, WebAssembly is already supported by all of the major web browsers. So you can create WebAssembly applications using any programming language you like that run inside Internet Explorer, Chrome, Safari, Firefox, and they run at native speed. So you can think of web browsers providing front-end support for WebAssembly, and DFINITY aims to provide the back-end support. So it'll be, top-to-bottom WebAssembly environment, and which you can develop for in any language you like. Now, of course, the purpose of this session is to discuss blockchain, networks, tokens, and regulation. And so it's important to say that the Internet computer is generated by a token-operated network. So I think we'll hear this expression more and more, token-operated network. And that means that tokens are used for installing software, for running software, for storing data, in the governance system that the network has, and also for something called mining, to remunerate people that connect their computers to help make this Internet computer. And it's important to say that you can't really design a decentralized network like DFINITY without tokens, because otherwise, how would you mediate participation in the network? If you didn't have to pay for computation, somebody could just upload some nefarious software to the network that just used up all the capacity. But this network liberates enormous utility. So we try and do this kind of grand bargain where we swap hardware and things like cryptography for simplification. So the Internet computer greatly simplifies software development, maintenance, and administration. And the purpose is to reduce the total cost of ownership. So we're using hardware and cryptography to liberate efficiencies in human capital. So the total cost of ownership of software systems comes right down, and we think by 75% or more. The platform's also hack-proof, so it provides a way to create far more secure systems and underpin better IT infrastructure. It never stops, loses data, and incorporates privacy technology that will make it easier for corporations to keep their data private and to create internet services that provide users with guarantees about how their data is used and who can access it in the future. And finally, of course, Dfinity is an open platform. So we like to think of Dfinity to the traditional IT stack, which is software and cloud computing and so on, as being a bit like the internet to AOL and CompuServe and those kind of early private networks. So there are four main areas where we think Dfinity has application. First is just private software systems. People can build better business systems on Dfinity that are more reliable, more secure, cost less to develop and maintain, and so on. Decentralized business infrastructures, things like supply chain platforms that are open and shared by entire industries with the aim of liberating, for example, capital from invoices through invoice discounting and gaining other efficiencies. Third application is decentralized internet services. We think that internet services will be reinvented as open source businesses. That means they're implemented using autonomous software, which is tokenized, and that can update itself. And that this will provide all kinds of special benefits to users. And also for innovators and entrepreneurs that want to integrate with other services. Right? And finally, of course, decentralized finance, although I think that'll be further down the line. So just quickly, if you're wondering, where did Dfinity come from? It is, of course, a decentralized system. You can trace back the origins to Bitcoin, which came out in 2009, through Ethereum, which created this smart contracts platform, through to where we are today. So just quickly, I'll wrap up by trying to categorize some different token types. We have cryptocurrency tokens, Bitcoin being the first example. Typically, they're created by their own network, so they're created by a network protocol. And they're typically volatile stores of value with approximately fixed supplies. Then you have network tokens. Dfinity provides an example. You need Dfinitors to pay for computation and install software and so on. And again, it's created by a separate network and a network protocol. And then you get into different kinds of tokens that are created by software running on top of platforms like Ethereum and Dfinity. So a popular token at the moment is called a stable coin. And an example might be MakerDAI. And these guys aim to create tokens with a stable value using algorithms and collateral and things like that. You have utility tokens. An example might be Numerai. Numerai aims to crowdsource trading algorithms for hedge funds. And you need a token to participate in a Numerai system. And finally, you have things that really do look much more like securities, where an asset token is a call on assets that are custodied for you by some organization. And an example would be Digix, which custodies gold and creates tokens against it. So that's pretty much it from me. I'm Dominic Williams, President and Chief Scientist of Dfinity. Finally, here's a video that was taken in the office a few weeks back. It shows the Dfinity test network, which is built from a few hundred computers distributed around the world that are connecting together to create a single internet computer. And that's developing all the time. That's it for me. Thanks.
Hey. Thank you. Good evening, everyone. I'm Bruce Sauce. I'm the Vice Chairman of NASDAQ, and I'm President of the NASDAQ Entrepreneurial Center. NASDAQ was built on the foundation of innovation and market disruption. The heritage continues to fuel our ambition, both in development of leading technologies and the way that we support great leaders through our nonprofit work here at the center. At NASDAQ, we believe there is exciting potential across the financial service industry to leverage blockchain. We're the first exchange to experiment with blockchain within its own operations. Within the NASDAQ private market, we ran a pilot that enabled private companies to successfully execute and document a private securities issuance on the blockchain. We're also leveraging blockchain-based voting and proxy assignment applications to reduce cost complexity in general meeting voting. Another pilot we've run with NASDAQ Talonin listed companies has also been going very well. Since blockchain is ideal for tracking and tracing, it can improve auditing and regulatory reporting, both from a quality and efficiency standpoint. So we've just kind of scratched the surface of blockchain at NASDAQ, but we do see there's great opportunities. That's why it's very exciting to have this panel of experts here tonight. So let me bring up, obviously we have Dominic, and we're going to bring up Olaf Carlson Wee. He's the founder and CEO of Polychain Capital. Come on up, guys. So Dominic says he's a chief scientist, so he's already made me smell like the less smart guy in the room, but we're going to turn it over to these guys to have a great conversation around the future of blockchain. So Dom, why don't you get started? Blockchain means a lot of different things to a lot of people. Could you give us a 1-minute definition of the word from your perspective?
So, broadly speaking, blockchain is a mechanism that makes it possible to create decentralized networks that provide some kind of service without any single point of failure or without a controlling organization. And you can build all kinds of things with blockchain. So Bitcoin is an example of a cryptocurrency built with blockchain. Ethereum is an example of a smart contract platform built with blockchain. And Dfinity is an example of an internet computer built using blockchain.
Right. So you talked about cryptocurrencies. Tell me, first, why don't you give me what do you think, how they fit into the whole blockchain world? And then Olaf, I'd like you to get your perspective.
So cryptocurrencies are one example of what you can do with blockchain. And they're relatively simple, at least in their current form. Typically they fix the supply of the tokens, and basic economics is if you fix the supply, the value of the tokens will vary with demand. But it's important to realize that you can do an awful lot of things with blockchain. So in the case of the internet computer, all of that software that's running on top of it is being powered by blockchain. And you can pretty much do anything you want with software. So blockchain can apply to almost anything.
Yeah, to add on that, I think that cryptocurrency, kind of digital gold or payment mechanisms, are kind of the first thing that has been created successfully in kind of a stable system. But I do think we are seeing more and more experimentation with more advanced types of financial contracts, things like stable or asset-backed coins, things like exchange order books that are operating in smart contracts, things like decentralized options or derivatives. So to me, we're seeing kind of a second phase of expansion beyond just simple store of value and payments to more advanced financial applications.